Okay, in this video we'll begin talking about the homework from chapter 3, section 5. And the first thing that we want to do is, looking at a graph, we want to describe the slope of the line. Again, I prefer to say describe the line. If we want to describe the slope of the line, we would say that the slope of the line in the number 5 is m is less than 0, which means that the slope is negative. Or we can say that the line is decreasing. Right? And we want to find the slope, so we're going to start from the left point, go down 1, 2, 3. So that's a negative 3. Then right 1, 2, 3, 4, 5. And so we have m is equal to negative 3 over 5. Now, why is it that we're interested in describing the slope first? Because if we can tell that the slope is negative, then when we come up with our answer for the slope, we have a way of checking to make sure that we got the sign correct. Second, number 6, we know that m is positive, so the line is increasing as we move from left to right. And let's measure the slope. We start at the leftmost point, up 1, 2, 3, 4. So I write a 4 there, over right 1, 2, 3. And so we have a slope of 4 over 3. Number 7, we have a horizontal line, so we know right away that m is 0. We can say horizontal. The line is horizontal and the slope is 0. In number 8, we see that the slope is negative. The line is decreasing. And if we're going to calculate the slope, we would start at the left point, go down 1, 2, 3, 4. So we have a negative 4 over 1, 2, 3, 4, 5. And so the slope would be negative down 4 over 5. All right, and so that's going to do it for these 4 problems. We will go on to the next set of problems. All right, then in this next collection of problems, we now have points from a line, but this time represented in a table. And so we want to still do the same type of things that we did before. I want to find the change in x as we go from negative 9 to negative 5. We're moving to the right by 4. Negative 5 to negative 1. That's up by 4, negative 1 to positive 3, up by 4. The y values, from negative 2 to 0, it's up by 2, 0 to 2, up by 2, 0 to 4, 2 to 4, again it's up by 2, and so our slope. Be careful because, again, the x's are on top, the y's are on the bottom, but when we calculate slope, we need to calculate them with the change in y over the change in x, so that would be 1/2. Once again, if we wanted to find this using our formula, we just assign any 2 of the points, x1, y1, x2, y2. We calculate the slope. M is equal to y2 minus y1 over x2 minus x1, and we would get 3 y2. Remember, you have to do the change in y, so it's y2 is 4, then minus negative 2 over 3 minus negative 9, and we would end up with 6 over 12, which is 1/2. So we get the same slope whether we do it using common differences in the tables or using the formula. So for number 10, we can simply notice that the y's have no difference, or that all of the points on the line share the same y coordinate, which has to mean that the line is horizontal and slope is 0. In the next instance, it's the x values that are not changing, so all of the x coordinates on the line are the same, and we would say that the line is vertical and m is undefined. Following this, number 12, we have change in x's appear to be going up by 1, up by 1, up by 1. Change in y's are going down by 7, down by 7, down by 7, and so. The slope is the change in y over the change in x, which should be a -7. If we wanted to use our formula here, m is equal to y2 minus y1 over x2 minus x1. Once again, we'll label any 2 points are fine, x1, y1, x2, y2, and fill them in correctly. y2 is -19 minus y1, which is 2 over x2, which is -1, minus x1, which is -4, and we end up with -19 minus 2, which is a -21, -1 minus -4, which is -1 plus 4, which is a +3, which gives us a -7 as well. So we should be able to calculate the slopes using the formula, using common differences in a table, using a graph, in any of these ways. Whatever is the most convenient method is fine for calculating the slope given whatever the context is. And we will stop this video at this point.